Welcome to The Explainer. Today, we're getting into the nitty-gritty of building a large language model. We're going to look at the architectural blueprints and the development toolboxes that, really bring these incredible systems to life. Okay, so you've decided you want to build an LLM. Awesome. But where on earth do you even begin? Well, think of yourself as an architect. Before you can even think about laying a single brick, you need a solid blueprint, and it's the exact same for an LLM. Your first, and honestly your most crucial decision, isn't about the code or the data. It's about the fundamental design. So we're going to walk through this whole builder's journey in 4 key parts. First up, that big initial decision. Then we'll get into a bit of a showdown, classic versus modern design philosophies. After that, we'll look at the tools you'll actually use to build the thing. And to wrap it all up, we'll give you a handy checklist to make sure you're making the right choice for your project. Okay, let's dive right in with your first big decision. Every great project, every skyscraper, every bridge, it all starts with a blueprint. And in the world of AI, we call this the model architecture. And this is the perfect way to think about it. Just like these columns define a building's strengths, its shape, its style, your model's architecture is its skeleton. It dictates how information flows through the system and ultimately what your model is even capable of learning. Now, this choice is a really big deal. It's not just cosmetic. Your model's architecture directly determines its ability to learn, to pick up on all the complex patterns in language, and it also dictates the raw computational power you're going to need. So it's this fundamental trade-off, right, from the start between capability and cost. So this brings us to a really practical question. If you're an aspiring LLM builder, you're probably thinking, okay, what are my options? What are the main blueprints that are actually available to me? What are the standard designs that everyone in the field is using? Well, the decision really comes down to 2 major families of architectures. You can kind of think of it as choosing between a classic, time-tested design and a much more modern, revolutionary one. First up, you've got the classic approach, recurrent neural networks, or RNNs. These guys were designed specifically for sequential data, like a sentence. They process it one word at a time, using a loop to remember what came before. And clever variations like LSTMs, that's long short-term memory, and GRUs, were developed to give them a much better memory over longer sentences. Then, in 2017, everything got turned on its head with the modern powerhouse, the transformer. See, instead of going word by word, transformers use something called a self-attention mechanism. It's this incredibly clever trick that lets the model look at the entire sentence all at once, weighing the importance of every single word in relation to every other word. And this allows for parallel processing, which makes them just dramatically faster and way more scalable. And when you put them side by side, the trade-offs are pretty stark. RNNs, with their sequential loops, are methodical. They're great for capturing that flow of time and language. But that step-by-step process is also their biggest weakness. It makes them slow and really hard to scale. Transformers, on the other hand, are built for speed. They're built for scale. But all that power is data hungry. And I mean really data hungry. They need massive data sets to truly shine. Of course, it's not always an either-or choice. Some of the most interesting work happening today involves hybrid architectures. By cleverly combining layers from both RNNs and transformers, developers can try to get the best of both worlds. The raw processing power of transformers with a deep sequential understanding of RNNs. Okay, so you've picked your blueprint. You know what you want to build. Now what? Well, the next question for any builder is, what tools am I going to use to actually make this thing real? And this is where development frameworks come into play. A blueprint is just a plan on paper, right? It's an idea. To actually construct your language model, you need a toolbox. And frameworks are exactly that. They are these software libraries that give you all the pre-built components, all the tools, and all the functions you need to assemble and train your chosen architecture. So, what toolboxes are the pros using? What's out there? Well, in the world of LLMs, 2 major frameworks really dominate the landscape. The 2 heavyweights in the ring are TensorFlow, which comes from Google, and PyTorch from Meta. TensorFlow is kind of the established veteran. It has a massive community and is fantastic for production-scale deployments. PyTorch is the newer challenger. It's often praised for being more intuitive, more what people call Pythonic, which has made it a huge favorite in the research world for super fast experimentation. So with 2 really great options on the table, how do you choose the right one for your project?
The question isn't really about which framework is best overall, but which one is the best fit for your specific needs.
So to make that choice, you've got to weigh a few things. First, what are your project's actual requirements? How big is it? Also, what's your experience level? If you're new to all this, TensorFlow's huge community might be an absolute lifesaver. On the other hand, if you're on a tight budget, PyTorch can be a bit more efficient. And are you just building a small prototype, or are you trying to build a massive, scalable system? Every answer kind of points you in a different direction.
And really, that's the bottom line. There is no single best framework. A research team that needs to iterate and experiment super fast, they might choose PyTorch. A huge corporation deploying a massive model, they might lean toward TensorFlow for its proven scalability. The right choice is the one that aligns perfectly with your goals, your team, and your resources.
Hey, if you found this breakdown of LLM blueprints and toolboxes helpful, do us a favor and share it with someone else who might be interested. And of course, please subscribe for more deep dives into these kinds of complex topics. So, we'll leave you with this final thought. We've covered the dominant blueprints in toolboxes of today: RNNs, transformers, TensorFlow, and PyTorch. But this field, it moves at lightning speed. So the real question is, what's next? What new architecture, what new framework is being cooked up in a lab right now that's going to completely define the next generation of artificial intelligence?